Hello, my name is Jacob Blaine Kristen. I work I'm principal software engineer at Rancher Labs, and I'm going to talk to you today about um, K3s and Rancher. All right. K3s is our lightweight Kubernetes distribution. It's really built for sort of low memory systems as well as ease of use. But you may find yourself asking, well, how lightweight is it? Well, it's about three. It's K3s, and K3s is 3 less than K8s. So there's that. But seriously, K3s runs on very limited memory. For servers, we recommend a minimum of 2 gigabytes, but according to what's on here, that can change depending on the backend database that you use. Typically, server systems that use that little memory use it. Typically, systems that use that little bit amount of memory are using an external database or SQLite on a single server. etcd systems tend to get a little bit fatter. That's because every node, as well as running K3s and the kubelet and some system level pods, is also then running etcd as an embedded process as well. And that takes up memory, takes up space. But agents can be very, very slim, and you can, as sort of witnessed here, and I can show it later when I demo, that information will be readily available. All right, so I stole a slide from K3s.io because it actually does a decent job of showing sort of what the process organization is here, right? So for Kubernetes, like we know we're dealing with a distributed system, and K3s makes some simplifying choices in that the kubelet, the scheduler, controller manager, tunnel proxy, API server, and tunnel proxy is the sort of the supervisor port in between in between nodes, as well as SQLite if you're running that, which is the default. All run within a single process, right? So that makes things pretty fast. And it makes the reconciliation loops or just go routines, and so they can check internal conditions and retries are not as common. And so K3s tends to start up pretty fast. One thing that sort of isn't here, which is that Containerd is actually run as a separate process that K3s listens to. And if Containerd fails, then K3s is going to fail. Otherwise, K3s keeps on running and it effectively runs as the kubelet. So that was, discussing the server, and the agent looks, very similar, except for it's, of course, not running the server controllers. And another thing that's running on the server that isn't mentioned here is the embedded Helm controller, which is used to install sort of static content that gets distributed with K3s, things like traffic, and making sure that core DNS gets installed via Helm chart, things like that. But given that that's not on the diagram, you can imagine it looks very much something like the agent half of the diagram, right? You've got Containerd and it's running pods, and those are orchestrated by the kubelet. And that's kind of pretty much it. But so I've said all of those words, and is it really, what makes it appropriate for the edge? What makes the edge a good target for K3s? And so we've talked about memory footprint. I've mentioned ease of use, in this case, operator UX. And I think that's a big deal. And kind of some of the ways that we achieve extra magic is, we adopt something that's similar to the Docker strategy of batteries included but optional, right? So K3s, when you boot it up, single node or multi-node, when you've got a cluster up and running, you've got a functional system by default. It may have made some choices for you that you don't agree with. And so if you want to replace core DNS because the installation doesn't do what you want it to do, or you want to run some other services, kubedns, you're free to do that by disabling core DNS. You know, if you don't want to run with Flannel, you don't want to run with traffic, you can run with other things by disabling them and making sure that they get deployed early by the sort of manifest drop-in directory. So that's really powerful flexibility, as well as just good reasonable defaults. Something else that's important, of course, is that K3s works with your favorite tools. All the tools we know and love: kubectl, Helm, K9s, anything that knows how to talk to the Kube API server should be able to talk to K3s, because K3s isn't doing anything special here. And then, of course, if we're talking edge, we're probably, if not talking heterogeneous architecture, we're at least talking about a range of target architecture. And so every build with K3s, we target and test extensively on AMD64. We run end-to-end test on ARM64 and ARMHF. We don't really have any good hardware for making that happen, but if it works on ARM, it should probably work on ARMHF, which is just V7 32-bit ARM. And then, of course, I've mentioned, or at least in the title, there was K3s and Rancher, and specifically I was talking about Rancher 2. And Rancher 2 is K3s aware, which is nice because you can have on systems that have installed Ubuntu on the nodes, and an upgrade time comes, you can actually have, Rancher knows how to orchestrate an upgrade of that with system upgrade controller, which is kind of cool. All right, so having said all that and mentioned some demo content, what we're going to do is run our demo. We're going to connect to an existing Rancher cluster. I'm not running Rancher. I'm running the Rancher agent on the ARM. I'm going to connect it to a local K3OS cluster that I have running HANCD, running a dev build of K3OS. And it's running sort of, I'm going to create a 2-node cluster. One is the leader, one's the master, one's the worker. And they are pictured here. And they are Raspberry Pi 4Bs with 4 gigs of memory, and I've got a 0.5 terabyte SSD external drive set on there. And that gets us timely writes, decent amount of I/O, and also it makes for longer-lived SD cards. So all I do is boot off the SD card and then pivot to the root file system on the external SSD. And I took those out on my desk and pictured them. That's what I'm showing you here. And I put them sort of away and behind because these are actually something that you can't see. These are, they've got Pi hats installed, which means they're running PoE, right? So I just plug an Ethernet cable and they get power and they go. And the Pi hats are a little bit hot and loud. And so I've got them behind the monitors, and hopefully the noise from them is not too loud and affecting this recording. All right, so let's end that slideshow and show you. Let's do, oh, I gotta switch screen share, new screen. Okay. Did that work? Screen share, a new screen. Okay. All right. So we've got a Rancher instance running here, and this is running on my local cluster, and I've already spun up sort of a 1-node. I've already connected the leader in this cluster and added it, just so I don't expose any secrets on the internet. And I can connect to this host here, which you should be able to see if I boop, 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 make that a little bit bigger. All right. some of my secrets are getting out here. Okay, so all right, so we want to get our node, and you can see we're running on Ubuntu 2004 LTS on Raspberry Pi, right? Hey, -A. All right, so maybe another one of the features that you're interested in is if you're going to be running embedded etcd, sort of, what maybe the usage is like. And Craig covered this on a recent meetup in September. But the etcd commands are essentially all prefixed by etcd. Excuse me. So we can do disabling snapshots. We can set the override the default schedule for snapshot retention, or for snapshot frequency, and then there's a retention value, and then there's the directory where those are saved, right? There's a lot in the server, and whenever in doubt, I always do the -- help and grep for what I'm looking for. All right, so we've got one node up and running, but I mentioned that we want to have a 2-node cluster. So what I'm going to do is connect to this node host. Okay, so K3s running here. There's no container D. All right, what we are going to do is, one thing I wanted to show. Another thing that Craig covered recently is the in the same September meetup is with the 1.19 release of K3s, we've added the ability to essentially externalize command line flags in a config file, in a YAML file. And that is by default here. And for the server, I've chosen to set the token to be demo, which is just sort of an arbitrary pre-shared secret between nodes for joining. And I've also told it to make sure the kubeconfig is world readable for my demos. I don't want to be writing sudo and worrying about path. So I've got that going on there. And you can see, again, another way that I do this is, oops, config. And so we see the config file, and the default is where I was showing you, it's Rancher K3s config.yaml, right? What this allows you to do is before you've even installed K3s, whether you're using the install script or doing it manually, you can lay down this file, whether via user data or some other provisioning mechanism to allow you to have a uniformly defined systemd unit file service definitions, which makes managing your installation a whole lot easier. All right, so that was another thing I wanted to show. All right, so let's get to here and let's install this thing. You can see, and this time I'm doing a curl, and I'm piping that into SH. And I'm going to use latest because currently stable is 1.18 series and latest is 1.19 series. It should be changing quite soon, but that is what it is right now. I'm making sure I'm setting my token, and I'm making sure that if I set this, that K3s knows that it's running an agent instead of a server. All right, so we've got that there. So we're going to pull down K3s for the architecture, verify it, set up the unit file, and boom, okay, we've got the K3s process running. And we should see that show up quite soon. So right now, what's happening is K3s is starting up, and and it joined, and then it downloaded the Rancher Rancher 2 cattle Rancher 2 agent, and deployed that, and then it connected, and we're good to go. And you can see that that's showing as a worker node instead of a control plane node. And so now I'd like to install something. Maybe let's try Pihole. So using a new feature of Rancher 2.5, you get this ability to control your Helm repositories per your cluster. And so I went ahead and set up the Pihole one, which is that going to show it? Yeah, right. So it's just going to this chart location. And let's go ahead and install that. So I'll go to charts, we see Pihole. All right, let's call it Pihole. I've never installed this, never run it. Let's see what it looks like, see how that goes, right? So one of the really cool things about Rancher is it makes it really easy to set up and consume various different charts, these installations, right? And if it doesn't know how to customize it, you've got the ability to edit your YAML, your values, .yaml before you run the Helm install. And that's really, really nice, right? Because if you're familiar with, sort of upgrading a Helm install, you make like an image change or whatever, you've got to make sure that you invoke it in the exact same way that you did before. And so you can, run installations via Rancher. And if you click on an existing one, you've got the ability to upgrade it, and you can edit your YAML right then and there, and it presents you with what you ran with before, which is really great. And all right, so I'm going to run this. Because we're talking about Pihole, this thing should be targeting AMD 64 architecture. And what's going to happen here is it does this starting thing for a little while. I'm not sure what it's doing when it's thinking, but it should be done. Here we go. Okay, so it looks like what it was doing was setting up running the installation. Okay, so if we go to installed apps, we see there's a Pihole. And that is up and running. Maybe can we customize the service? Something I forgot to check when I was doing it. Here we go. Node port. Oh, okay. So what we can do is we deploy that into default. So let's cube CTL, there we go. Oh, I'm on the wrong host. Here we go. All right. So what we've got is we've got node ports. Where is that? Running, there's no. Oh, you know what we're going to do? We're going to upgrade this sucker and set it to load balancer. Ooh, I wonder if that's going to run. This is one of the limitations when you run with the default K3s, is you've got service load balancer, which is a really rudimentary load balancer. All it does is look for the port that it's trying to serve, and it tries to find a node with that port available. Turns out this wants to connect to port. It wants to share on ports 53 and I think 80 and 443. 80 and 443 are taken up by traffic, and 53 is taken up by core DNS. So unfortunately, that's not going to work. All right. Let's go ahead and delete that. What's it going to do? All right, we got rid of the Pihole. Okay, let's try something a little more fun. As you can see, I've got a Minecraft chart here. Somebody has, let's see, let me show you what that is. Somebody's built a Minecraft container and handily built a Minecraft chart for us. So let's see if I can get that working. I mean, provided we've got images available, and I believe that we do. Yeah, we've got a multi-arch image for ARM64. So we're going to, like that, we're going to call this demo. Let's call it creative, why not? All right, so we want to customize our YAML here. There's a trick to this one, which is do it true. Anyway, so running a Minecraft thing is actually, you might not expect to do that with a Pi, but it's, if you got kids that like to play it and you don't want to pay money for realms, hey, guess what? You can do this. All right, so I'm going to set it to use, you should only need about 2 gigs for a server, but you're going to need a decent amount of CPU. All right, and so one thing that we're going to do is set the service type to load balancer, because service LB will find a port for that. The default port shouldn't be in use. And we need to override the image name. This is pointing to a manifest, and so that should be able to pull down an Arch AMD, or I'm sorry, ARM64 image. All right, so I think that was all that I needed to do. All right, let's see if this works. All right. So we're downloading the image. Hopefully I didn't typo anything. Everything should work pretty well. This is always the queasy stomach part for me. So again, what we're doing is attempting to install a workload via Helm chart running on a Raspberry Pi cluster. All right. I remember this being faster when I ran the demo. All right. So that thing is up and running. Okay. And so this deployed to 216 host, which is RPI1, I believe. Yep, RPI1. Okay, picked a port. Let's see if that works or not. Happen to have trusty Minecraft launcher up. Oh, it started on a different screen for some reason. So here we are. Let's Let's see if we can connect to that one. Server is out of date. I'm not sure what that means. But it looks like we're connected. What's going on here? Oh, it's so fun when you run these tests. I did run a demo of this earlier, and it ran super fast. Let's do this. Let's delete. Connection. Let's try. Yeah. What's going on here? Okay, folks. Looks like we connected to a jungle biome. Oh, this is what happens when the machines are slow sometimes. You know, a little bit of lag and blocks. But I am now running a Minecraft instance on my own personal network. I was hoping for something a little more scenic than a jungle, but that's what you get. All right, cool. I am super stoked that that worked. Okay. All right, so that's pretty much the end of my demo. I mean, the idea here was showing running multiple workloads, how easy it is to get up and running with K3s and Rancher in an environment with very limited machines. I guess one thing that I can show that I didn't explain very much is if I order this by memory, you can see that the K3s server itself has about 630 megs of resident memory. If I expand this upward, ooh, lots of threads. It was actually, let's see, container D, and it's ordering these by memory. So the next thing is the agent thread, which is essentially something that every node runs. And then there's container D, right? And so if we pull up htop on the, on the second instance in order by memory, we'll see, oh, yeah, Java taking up decent amount of memory. But then there's container D, 147, and I believe the agent is with, again, roughly about 130, right? So you're talking about 300 megs for a system that's running just K3s and container D. Let's see, so let's go back to cluster manager. I want to see if that information shows as, yeah, so I gave it 2000, so we've got 2 cores. Why is it 2 cores here? I ended up running on the 16 hosts. Did it move? Interesting. Anyway, so Rancher on K3s on Raspberry Pi and Minecraft via Kubernetes. All right, that's it, folks. Thanks for listening, and we'll be in the chat to answer your questions afterwards.